Alright, let's have a look at problem 494, target sum again. So for this problem and in this video, we're going to explain how to transform this problem to be a standard 0-1 knapsack problem, and then we solve it using the classic or standard dynamic programming method. So first I'll give a quick summary of the statement of the problem, and then we will look at the reformulation of the problem, and finally we share the short code. So first, the statement of the problem. And basically the statement of the problem says that given an integer array called nums and an integer target, so we want to put positive sign or negative sign in the elements of nums, and then we do summation. So if the sum equals to target, so we get a way of making the target. So the question asks to return the number of different ways we can make expressions which evaluates to the target. So that's the statement of the problem. So in example 1, so here are 5 ones and target is 3. So the output 5 means there are 5 ways of putting positive or negative sign in front of each number, and then sum them together to get 3. So that's the statement of the problem. In a previous video, we used a dictionary and check method to address this problem. Here we are going to share another method, which is the dynamic programming method, after we reformulate this problem as a 0-1 knapsack problem. So let's first look at the reformulation. So the method 2 here is we are going to use the method to solve the 0-1 knapsack problem. In other words, we want to use dynamic programming. So for method 1, so you are encouraged to check this video, so to have a feeling about the previous method using dictionary and check. So here, if we want to use dynamic programming to solve a 0-1 knapsack problem, so the main question is here, how to transform the original problem here to a 0-1 knapsack problem. So actually the procedure is sort of easy, I would say. So if we write down the formulas, so assume the nums list elements are given as a0, a1 up to n-1, where n is the length of the nums list. So here I'm using a0, a1 up to n-1 is just for convenience. And assume that the sum is s, so the nums list has a total sum capital S. So here we want to emphasize that once the nums array is given, so their sum actually is fixed, right? So here I'm going to use n equals 5 to fix the idea. So basically the above sentence tells us the trivial thing. So add them together, we get a sum S. So assume that we have a or any choice of plus or negative that makes the target. For example, if we put a positive sign in front of a0, so and put negative sign in front of a1, positive in front of a2, positive in front of a3, and negative in front of a4. Assume this is a valid choice of signs to make a target. Then what we want to do is we add these two equations together, so this one and this one. So if we add them together, so those we choose positive will have doubled. So here a0, here another a0. And those we choose negative sign will cancel. For example, a1 and negative a1, and a4 and negative a4. So the overall result is twice of those with positive signs equals the sum plus the target. So if the sum S plus target equals is an even odd number, then we're going to get A0 plus A2 plus A3. In other words, those with positive sign equals nothing but the sum plus the target integer division by 2. So in other words, this problem actually finding or put positive sign or negative sign in front of these numbers to make it equal to target is transformed to the problem of selecting a subsequence from the arrays such that so this sum up to s plus target integer division by 2. So that's the problem. So again, let's state that so to fix the idea. So originally we have A0 up to a minus 1. We want to choose a subsequence so corresponding to those with plus sign. So we want them add up to s plus target divided by 2. So here divide is integer division. So that's the transformation. So this is nothing but the standard 0-1 knapsack problem. So those does not appear in this formula or in the left side of this formula means that we do not choose that. So those here appearing means that we want to choose those items, right? So that's exactly a problem of choose or not. So in other words, we changed the target to s plus target integer division by 2 and then transform the problem of plus or negative sign into a 0-1. In other words, choose, not choose or choose problem. So that's the process of transformation. So once we have done this transformation, then solving the 0-1 knapsack problem is a common practice, right? So now we are ready to write the code. So but before we do the writing, I'll share some challenges. And the first one is, can we further simplify the format of the solution code we are going to share here? So this is one. Secondly, can we compare with the direct dictionary and update method and find the connections of the two methods? So that's actually very interesting to compare. If we think a little bit deeper, so we can maybe establish the intuition that the two methods or code format are sort of equivalent. So with that said, let me do the code. So here, first step, I'm going to track some information and do some set case treatment, preparation and set case or edge cases. So first, I'm going to track the sum s. So it's the sum of nums. And then, as we mentioned here, so s plus target is always equals to twice of the numbers we have chosen. So in other words, we want to make sure s plus target is an even number, right? So the edge cases can be treated as follows. So if s is less than the absolute value of target, or s plus target, so integer division by 2, so is not 0, we're going to return 0. In other words, we cannot make target. So the first case is very easy to understand. So if we want to choose all positive sign in the nums, so we are going to get the sum, that is s. So if s is less than the absolute value or target, so it's not going to make it. Or we choose all negative sign in nums, we're going to get negative s. So if in this case the absolute value of s, if it's less than the absolute value or target, we are also not making it. So the second one is clear from this transformation of the problem. So in this two edge cases, we're going to return 0. So next, we are treating the general case for the 0-1 knapsack problem. So for this, I will just write a knapsack helper function. So for this, I'm not going to write every single details because it's quite a common problem. So for this, I'm going to define a function called Knapsack. So the argument is one number called target. So what we want to do is basically dp. So dpi basically means the number of ways up to sum to I by nums so far, right? So with that interpretation explicit, so we are going to iterate for the nums array. So before that, let's make some initialization. So here 1 plus 0 times sum. So here in this dp table we have s plus 1 terms. So the first or zeroth index atom corresponding to dp0 equals 1. In other words, if we want to make 0 out of nothing, so there's only one choice. So that's the interpretation. So now we are going to iterate for num in nums. Then we're going to update the dp table if we want to use this num. So we're only concerned about those j that is larger than num, larger or equal than num in the dp table. Otherwise, if the j is less than num, we couldn't choose num at all. So in other words, for j in range, so I'm going to iterate from the very large to up to num itself. So in other words, from s so to num minus 1. So we're ending at num, so we're going to use num minus 1, and the increment is negative 1. In other words, each time we're going to decrement by 1. So then the dpj update rule is trivial, so it's dpj minus num, right? So from the its own base, the original state, then increment this dpj minus num. So the interpretation is that so there are dpj minus num number of ways to make j minus num. Then if we want to make j, so we add that num to j minus num. So there are dpj minus num number of ways increment, right? So that resets the state for dpj. So with that side, we're going to return dp target. So that's our hyperfunction. So with that side, so we're ready to do the return. So what we want to return is nothing but knapsack. So s plus target interior division by 2. So this is always a division without a remainder, or the remainder is 0 because we have already treated the edge case, right? When division by 2 is not 0 remainder case, we are going to return 0. So here we are going to return knapsack s plus target interior division by 2. So with that said, let's first do a simple edge case check and then do the generic case check. Yeah, it passes the first example. Let's check for the generic case. It also passes the generic case. Yeah, for this problem, I guess the main point we want to make is that we can transform this problem to be a standard 0-1 knapsack problem, and then we use dp to solve this problem. But if we compare the code of here and with the code in our previous video, and we think a little bit further, so we find that, or we have a feeling, so these two actually follows the different line of ideas, resulting in different formats of code, and essentially So if we check the opposite rules, there's a sort of the same. So that's basically a thought or a feeling. That's about it. Thank you very much.